Hello, let's look at part C. So, if the incline is rough and the hoop rolls, so this time we have a thin hoop of mass m and radius r rolls up the incline as shown with an initial speed v0 in the position shown. If the incline plane is rough and the hoop rolls up the incline without slipping, determine the maximum height which the hoop will rise in terms of capital H and the given quantities. Okay, so that one we are also going to set up using energy. So we have our EI equals EF. And for that one, the reason we're setting up with energy is because that will, once again, be the easiest, similar to sort of A and B as I talked about earlier. We could try to set up with torque, okay? So we'd have to use both torque and Fnet, so torque net, Fnet. Find an acceleration, okay, and then you would use kinematics to find out the height, that distance that it can go with that acceleration, okay, based on the initial velocity. But that's going to be a lot of work. Energy is definitely the easiest possibility for this. So the type of energy we have at the beginning, well, we know it is moving, so that's just kinetic energy, linear kinetic energy, but it's also rotating, so we're also going to have KE rot, okay? So we have KE plus KE rot equals, and then at the end, it's not going to be moving anymore, right? Because if it was still moving, they'd be going up, right? It'd still be moving up. So we know it's not moving. So the only type of energy left will be PEG, okay? So we're gaining potential energy because we've gone up a hill, okay? So we have 1/2, formula for KE, 1/2 mv squared. So I have 1/2 mv squared plus KE rot is 1/2 I omega squared equals mgh. Okay, remember this h here is capital H, and once again, that's what I'm trying to solve for. I gotta find this h, okay? Now, I can't leave I or omega in my answer, right? But I can transition those things to things I do know. So I have 1/2 mv squared plus 1/2. This is a hoop, okay? Thin hoop, which means that all of the mass is going to be at radius r, okay? So that means my moment of inertia is going to be not 1/2. It will just be mr squared, okay? And then remember, I can't leave omega in my answer because that's not a given. They didn't give me that variable, but I know that omega r equals v. So omega equals v divided by r, and if I square all of this, I get omega squared equals v squared over r squared. So I have v squared over r squared equals mgh. Okay. Now you'll notice there is an m in every single term, so I can go ahead and cancel that out. Okay. And so I have 1/2 v squared plus, this will be 1/2 v squared. Remember, these r's will cancel. Sorry, this is also an r squared. Remember, coming from here, we have an r squared, v squared, so that's v squared, r squared. Okay, so those two r squareds will cancel, and this will equal gh. So I have v squared equals gh. I apologize, that is a capital H, as the problem defines the height as a capital H. And so to solve for h, h equals v squared divided by g. Okay, and so that one is a little tricky, but not too bad, okay? And so this means that my original h, this new h, okay, is going to be double the old h, okay? So if we look at what the problem says, in terms of that capital H, right? So this is equal to 2h of the original h, okay? So if part A, right, v0 squared over 2g, that's h, then this right here is going to be double that, right? So the height we have for this will just be 2h, which is equal to v squared over g, okay? So that was part C.